Okay, so now that we have our minds wrapped around what logarithms are, let's see what we can use them for. I mean, they gotta have a purpose, right? So they're used for mainly solving equations where you find the variable stuck up in the exponent because logs allow you to find the exponent, yes? So we're gonna look at two different methods for solving these guys right now. One way to deal with this would be to take the log of both sides. And I'm going to go ahead and take the natural log of both sides. So natural log of 2 equals the natural log of e to the 0.0525t. So now this exponent can come down in front, 0.0525t times the natural log of e, but oh wait, natural log of e, that's 1. So this is just 0.0525t equals natural log of 2. We can divide both sides. We get t is approximately 13.2 using 3 significant digits. Okay, so that's one way. I'm not a fan of taking the log of both sides, to be honest. I prefer to change into the logarithm that is the most appropriate for the problem. And the base of the exponential that we're trying to solve is e. So let's change this equation into its equivalent logarithm equation. So we're going to go log base e, so natural log of 2 equals the exponent, 0.0525t, and we divide again and we get right there. Changing into the log that matches the base that we have is very quick and very handy. This doesn't work so well if we have powers on both sides of the equation, but when it's a power equal to a number, change to the appropriate base. If you got different bases on both sides, well, then you need to take the natural log of both sides. Or, as you'll see in the next problem, we can take the common log of both sides. So I'm going to start by taking log of both sides. Common log base 10 of 3 x minus 4 equals the log of 24. And so the exponent can come down in front, x minus 4 log 3 equals log 24. Now I can divide both sides by log 3. And remember, log 24 divided by log 3, that absolutely does not equal log of 8. There's no log property that allows us to combine these together. We'd have to type this into our calculator. But then we add 4 to both sides, and we find that this is approximately 6.89 to 3 significant digits. Using method 2, my method of choice, let's switch to the logarithmic equivalent of this equation. So we're going to use log base 3 of 24 equals x minus 4. And you might ask, well, how is that the same? Well, guys, take a look at this. That thing right there, that's the change of base formula on that. But now we add 4 to both sides and we get right back to that. That quick, that simple. Solving log equations is pretty straightforward. And you know what? If we wanted to, we really could use our calculator to solve a problem like this, looking at a graph. Next problem, oh my gosh, there are 2 logs separated by a plus. It's a sum of 2 logs. Oh my goodness. Well, guys, we have some properties to help us with this. We can change this into one logarithm. We have some properties that can help us with this. We can change it to one logarithm, combining these together with multiplication. So now we have log equals number. Now we can change to exponential form. 2 to the 4th equals 10x minus x squared. Well, this is a quadratic. X squared minus 10x plus 16 equals 0. And that's factorable, in fact. X minus 8 times x minus 2. Zero product property says that x is 8, or x's too. And really, ladies and gentlemen, we should take these back up here and verify that they both work. It is possible with logarithms to get extraneous solutions, which means we did everything right, but somehow we got an extra solution by manipulating the equation. In this case, if we check log base 2 of 8 plus log base 2 of 2, that does equal 4. And similarly, if we plug the 2 in for the x's. But you always should be checking these for extraneous solutions. So now, last example for today, last thing to talk about. I know you're overjoyed with happiness, but how do we solve this bugger? This is an inequality. Ooh, fun times, right? Fun! Yay! Everybody cheer. So, what do we do? How about we expand? E to the x squared plus, doing inside and outside of FOIL, we get 4e to the x minus 12 less than or equal to 3e to the x. Okay, so, well, this is actually a quadratic, guys. We have something squared plus 4 times that thing minus 12. Let's move the 3 to the x over. And if you have trouble seeing this, what I'd suggest doing is say, let t equal e to the x. So then this equation becomes t squared plus t minus 12 less than or equal to 0. And that might be a little bit easier for you to digest than having to factorize or apply the quadratic formula or some other solving technique on this actual quadratic equation. So here we go, let's factorize. We get e to the x plus 4, e to the x minus 3. And now we're going to treat this as if it were an equation. E to the x plus 4 equals 0. E to the x minus 3 equals 0. So e to the x equals negative 4. Well, ladies and gentlemen, that can't happen. E to the x equals 3. X is the natural log of 3. Exactly. There is nothing that we can raise e to and get negative 4. Okay, so now how do we know what to do with this? Well, let's make ourselves a handy-dandy sign diagram with natural log of 3 on our number line. So at natural log of 3, if we think of this as being, this side as being our function, or I guess this right here, that equals 0. On this side, e to the x minus 3, if I plug in something smaller than natural log of 3, e to the x minus 3 is negative and positive over there. E to the x plus 4, if I pick something smaller than the natural log of 3, this is positive. And on that side, it's also positive, e to the x plus 4. So when I multiply them together, e to the x plus 4, e to the x minus 3, to the left of natural log of 3, we have a negative product. To the right, we have a positive product. So what values of x will work? Well, x being less than or equal to, because we can equal 0, that's okay. We get x is less than or equal to natural log of 3. Well, how could we use our graphing utility to help us out with this, guys? Well, let's add a graph. And in my graph, I am going to put the original function in. E to the x minus 3 minus 2 e to the x plus 6. Enter. There we go. Beautiful. Isn't it nice? And then I'm going to put in 3e to the x. And we'll graph that. And moving our graph so we can see the point of intersection right here. Guess what point that is, guys? That's the natural log of 3. So here's the graph. This is natural log of 3 at that point. We could find that point of intersection, but we want the red one to be less than the black one. So the red one being less than the black one is down here, and if we're using our sign diagram, here's that natural log of 3. This part is over there, so again, x is less than or equal to natural log of 3. So there we go. All kinds of solving joy and bliss involving logarithms and exponentials. I hope that y'all had as much fun as I did.